Good morning to all. Myself, Dr. P. Sabrinath, Associate Professor in the Department of Mechanical Engineering, SRM Madurai College for Engineering Technology. We are seeing about the videos for subject Basic Civil and Mechanical Engineering. Already in the previous few videos, we have covered what is the overview of mechanical engineering, what are all the various sub-disciplines of mechanical engineering. We have also studied in detail about automobile engineering, manufacturing engineering in a separate videos. And this is the last part of the unit 1 overview of mechanical engineering, that is interdisciplinary concepts in mechanical engineering. So mechanical engineering in association with the other departments, how it collaboratively is working, they will be covered in this interdisciplinary concept. Because most of the mechanical engineers, mostly they will go for core mechanical engineering field for their work. Sometimes they have to work for some other interdisciplinary field also. So in that aspects, how the mechanical engineering helps the engineers to work in an interdisciplinary manner with other departments. Those aspects only we are going to see in this lecture. So mechanical engineering is inherently interdisciplinary because in the basic definition itself we saw it derives the principles from physics like mechanics, statics, dynamics, kinematics, kinetics. All these comes under physics concepts, and also the laws like Newton's first law, Newton's second law, Newton's third law. Everything will be applied in the mechanical engineering discipline. Similarly, materials and metallurgy is one vast area that also we have to work in collaboration with mechanical engineering because the design we have to select the proper materials. So the success of any product depends on the correct and proper selection of materials to withstand the forces, to withstand the heat. It should not lose its property like that. So that is a very vast area. So in collaboration with material science people also, mechanical engineers have to work. So we mechanical engineers should know about material science and metallurgy concepts also. Similarly, it involves lot of mathematical calculations. So we have to derive the concepts from mathematics also. So mechanical is automatically interdisciplinary. So you have to get the concepts from physics, you have to get the concepts from mathematics, you have to get the concepts from material science, and other fields like latest technologies like computer technology, electronics technology also needs to be combined to design, analyze, manufacture and maintain the mechanical components. So this is covered under this interdisciplinary concept. So the integration of knowledge allows mechanical engineers to work across diverse sectors including robotics, biomechanics, aerospace and manufacturing. So some engineers will mainly work in the core mechanical industries. They will use only mechanical concepts. Now the technology is advanced. So suppose if a mechanical engineer is going to work in a mobile company, so he should know about mechatronics concepts. So suppose he is going to work in a robotic company, so he should know about the manufacturing of robots. Similarly, in the medical field, as biomedical engineering, now robotic surgery, production of surgical tools. So all these covered in the under this interdisciplinary concepts of mechanical engineering. So let us see one by one. The first and foremost thing is biomedical engineering. So mechanical engineers apply their knowledge of mechanics, materials, and design. So mechanical engineer will be thorough in the concepts of how to design a mechanical component. So they will be in their course of study. They will study various subjects like design of machine elements, design of transmission systems. So all these, and similarly for analyzing part, we have finite element analysis. Lot of softwares are available like ANSYS. Similarly, for drawing of components, we have many CAD softwares like AutoCAD, Pro E, CATIA, graphics like that. So all these things they will be very much familiar how to design a component, how to draw a component in a system, how to analyze the everything they will be in familiar for mechanical components. Suppose if you are going, they are going to work for a biomedical field. So suppose a robotic surgery. Nowadays, all the doctors instead of manually cutting the entire part, mainly they are going for laparoscopic surgery. Just instead of cutting the all parts of the body, just they'll put a few holes, one or two holes, and they'll insert the latest tools. They will have all sensors, cameras, so the inner parts will be seen in the monitor. So with the help of that monitor, they can easily find out the tumors, and they can easily cut the tumors. They can do the surgery very much easier instead of openly cutting. It will be very much difficult for the patient also and doctors also. Now with the help of advanced technologies, with the help of this laparoscopic surgery, only a small portion of the body part will be cut, and by inserting the specialized tools, they are doing the surgery. With the help of robots also, they are now doing the robotic surgery. So for all these things, we have to design and develop the production of surgical tools, prosthetic materials, medical devices. All these are covered under this biomedical engineering. There is a lot of scope for biomedical field. So biomedical field and mechanical engineering also can work if they have these interdisciplinary ideas. The next one is robotics. For robotics, uh, this comes under automation system. So majority of the industries are going for unmanned factory, automation. They are reducing the manpower. So manpower, there is a chance for a lot of human errors. So if you do a program with the help of a robotic, the errors will be completely eliminated. So we can increase the production, we can reduce the cost. So for that, many of the industries now going for automation. So in automation, mainly they are going for robotics, AGVs like automated guided vehicles for transporting the material from one place to the other place. So we have to design various types of robots are also available. Pick and place robots, humanoid robots, various types of robots are available. So for designing and development of robots, mechanical engineers mainly used. So mechanical engineers, they have the concepts of some electronics, some computer technology. Then it will be very easy for them to design the mechanical parts of the robot, and also to integrate the functioning. We need electronic sensors. Then we have we need some softwares also. So that comes under computer technology. So if you have a knowledge in computer technology, programming concepts, software tools, electronics principles, electrical concepts, as well as mechanical engineering concepts, then it is very easy for any mechanical engineers to work in the robotic industry to design and develop the robots, so that we can easily implement the automation concepts. Similarly, next interdisciplinary concept is aerospace engineering. Now, most of the mechanical engineers work in the field of aerospace engineering also, for designing, developing, analyzing, and manufacturing of various aircraft and spacecraft and propulsion systems. Here also they require expertise in thermodynamics, aerodynamics, selection of materials, metallurgy concepts. So if you have thorough knowledge in design of mechanical components, aircraft also a lot of mechanical components like shaft, couplings, springs, flywheels, shaft, everything will be used in aircraft also. In addition to that, you should have some knowledge about the aerodynamics. If you're thorough in aerodynamics concepts also, it will be very easy for a mechanical engineer to work in the aerospace industry, and also to design the aircraft and spacecraft. In that also the use of say electronic concepts, computer technology is also required. So this is about aerospace engineering. Then last one is mechatronics engineering. Now we have a separate course in BE mechatronics also. So it is integration of mechanical plus electronics. It's called mechatronics. So whatever we study in electronics and communication engineering concepts, it is merged with mechanical systems to produce mechatronics components. Examples of mechatronics components includes robotics, sensors, smart watches, all CNC, computer numeric control machines, all comes under the concepts of mechatronics. So it is interdisciplinary field that combines mechanical engineering, electronic concepts, and computer control systems to create intelligent machines and systems like CNC machines, robots, smart watches, smartphones, laptops, everything comes under mechatronic applications only. So in mechatronics, we use various sensors to get the feedback, measuring the distance, measuring the temperature, measuring the pressure, measuring the velocity, measuring the acceleration, measuring the flow. For all these things, we use separate sensors. So they will give the feedback also. So from the feedback from sensors, we can control a closed loop system without any manual intervention. So, and other components like microprocessors, microcontrollers, PLC, programmable logic controllers, all these electronics items will be incorporated in a mechanical system. So, pure mechanical based control system will be converted into electronics based control system. If you take a car, the traditional car, everything will be controlled by manual system. Now, if you take a latest car, operating principle, everything is mechanical only. The engine, the piston, connecting rod, crankshaft, fuel, everything is mechanical system. But we control the system with the help of electronics principle. Everything is now coupled with the sensors, and we have a computer technology also. It gets a feedback from sensors, and the computer softwares is used to analyze that feedback from the sensors, and based on that, it is controlling the car. Now, driverless cars also now coming into picture. Without any drivers also, we can drive the vehicle. For that also, fully mechatronic system is used. All type of sensors to get the feedback from the sensors through the electronic items like microprocessors, microcontrollers, PLCs will be used for the controlling of the system. This is an example of mechatronic system. Similarly, mechatronics is used in all field like mobile phones, smartwatches, all computer numeric control machines, CNC machines, CNC lathe, CNC milling machine, everything is now programmed. No workers required. Everything is now pre-planned as a programmed using G codes and U codes. And once you feed the coding in the CNC machine, everything will be the machining operations will be performed automatically with the help of robots and AGVs for moving the tools from one place to other place, and picking and placing the tools and job. Robots are used. So it is unmanned factory. It's an example of unmanned factory. So for that we use mechatronics system. So as a conclusion, what we can say is mechanical engineers should know the other disciplines like physics, maths, thermodynamics, aerodynamics, electronic concepts, computer technology, software technology. It will be easy for the mechanical engineers to work in any field of engineering like robot field, biomedical field, aerospace engineering, mechatronics engineering. They can easily get a job, and that is the future of mechanical engineering. So with this, we have covered the entire overview of mechanical engineering, starting from the introduction about definition of mechanical engineering, what are the various subdisciplines of mechanical engineering, finally the interdisciplinary concepts in mechanical engineering. Thank you.